Hello everyone and welcome back. So finally we get to this point where we will split the lines to create the split effect that we're all after. Sorry if I didn't did this sooner, but I was busy doing other projects and now we will continue on this one. So you'll have to bear with me because I've done this some time ago and I might not remember some things, but we will try to do it step by step. So if you remember, we have a group in here. So let's see in primitives. No, where is that? Boundary on the point. So we have a group for the boundary. So we want to promote that to primitives. So we can later have it available. So let's promote to primitives and the group is the boundary. And as you can see, it's only selecting those primitives around that we created some time ago somewhere on this scatter setup and we still have it. So that's fine. Now let's go through the breaking. The thing is we need to rebuild these curves and we need to rebuild them twice because we want curves on this side and curves on this side and we need to create some sort of break threshold. It's not an easy task guys, but let's try to do it the proper way. So let's create a wrangle. And since we want to create geometry, let me just focus on this. Since we want to create geometry and not use this one, we will connect it to the second input. And we will have nothing in here, of course. And let's just name it break lines. And I'm just gonna color it, let's say pink. Oops. Okay. Now we could do this in detail mode, but another option is to do it by numbers, which will be much faster because this will take advantage of all the CPU, all the cores in your CPU. So it's parallel processing instead of doing just once with this detail. So let's do it by numbers. And how many numbers we need? Well, we need this amount of cores. So we have 548 prims. So let's do in here n prims, and the input is the 1. So this is how much we will iterate, and this will all be processed in at once, since we are using these by numbers. So let's create, first of all, we want somehow to carve, first of all, these curves. So let's create in here, before we do the carving, let's create the number of points that we will need to generate. So int number of points, it will be equal to prim points in input 1 and I at lm_num. So we want to create all these points and we want of course the length of the prim points, and since we want to split it in half, we also need to divide by 2. So that's the amount of points we need. So for each prim we get the amount of points and we divide it by 2 since we want to split it in half. So that's our first step. Then we need a carve, so a carve parameter, so we can decide where to split those lines. And that's just going to be a channel float called carve. And I'm going to set it for now as 0.72. We can decide that how we do it later. And now we will create a loop. And we will need an extra loop to split them in half, but for now let's try to do this step by step. So I can even help myself remembering how I did this. So we'll create a loop for, and we will initialize a variable called I, and it will be equal to 0. This is just to rebuild the curves. And then we will do I is less than number of points. And if so, we increase I plus plus. Now, how are we going to rebuild? So I'm clearly doing something wrong in here. So len prim points 1 I at lm_num divided by 2. Len, sorry, I need to close in here. This is the length and then divided by 2. Sorry. So the way we're going to rebuild these curves is using primuv and a u attribute or uvw. So first of all, let's create that u attribute, which will be based on the curve. So float u, it will be carve multiplied by the current iteration, and then we need to normalize it to 0 to 1, since the u attribute of the UVW takes numbers from 0 to 1. That's like a curve u along the curve, and so we just do a number of points minus 1. And then we can just, for good measure, set the UVW parameter or variable, which will be just set u and 0 0.0, 0 0.0. So you can just use u, but just since the prim_uv expects a vector, we can just recreate this. That's fine. Now let's grab that point position. So vector pos, it will be equal to prim_uv. So prim_uv, and we want the first input, the second input. Then we need to grab the position. And the prim number, it will be the lm_num. So it is like prim_num or pt_num. It's just the element that we are iterating over. And since we have the number of primitives of the first input, this will just match the target primitive. I hope that's clear. So then we just feed the UVW, and we should have the position right now, which let us just add the point. So int point, it will be equal to add point, and we will add it to this input and just feed the pos. And now you can see we can carve, and we have all the points of this geometry. So let's see, 22,000, and we have 10,000 in here. So we should, oh, we divided by 2, of course. So we divided the point numbers by 2. Otherwise, we would have the same amount. So as you can see, yeah, we have the same amount, because in here we divided by 2. And we will still need that, so let's keep that. And as you can see, we now have the ability to carve. But then again, we need to create, of course, also the primitive. We need lines, not only points. So let's do that. So inside this for loop, let's create a primitive. So int prim, it will be equal to add prim, and we want a polyline. Polyline between quotes. Now we do have the prims, but we also need to create the vertex to connect those points. So right after adding the point, we can add the vertex, and this will be the outputs, the prim that we saved, and the point. And now we should have the lines, and we don't. So add prim, polyline. Oh, sorry, we don't want to do it inside the loop. We want to do it outside, of course. So we want to do it in here. We don't want a prim for each point, of course. And now we have the prims. So basically we have the same, just half of the points, but we have the ability to carve. All right, now what's next? After this, we want to break in half, since we want to do this carving in half. So we will need yet another for loop. So outside, let's clean this one a bit and give it a tab, and let's do for, and let's name it int prim split, and it will be equal to 0, and we just want to split in and half, so we will do prim split is less than 2. We just need 2 iterations, and then we can do prim split plus plus. That's fine. And let's close in here this one. So for in prim split 0, prim split less than 2, prim split plus plus. Oh, we need to open in here, sorry. It's fine. Now it's just creating is not what we want. We want this inside. So we create 2 prims on each iteration. So that's fine. So first of all, we will set in here the carving to be around 0.72. And then, so we will need to invert this u if it's the other prim around. So let's do U. It will be a select, just like an if select, and we will select based on the prim split, and we will, if that's true, we will do 1 or U, otherwise we invert, so 1.0 minus U. And now we should have two prims around, and if we do the carving, you can see that it's splitting in half. Okay, that's fine. Now, what else do we need in here? So we also need to do this carving based on the perimeter. So for that, after the carve, let's do a float perimeter. It will be a prim intrinsic, and we want to read the measured perimeter. That's correct, based on the prim num, which will be I at lm num. So that's fine. And now we want to do this carving. So where we have this carve, we want to do carve. It will be select. And if the perimeter is bigger than a break threshold that I'm going to establish, so break thresh. So let's have a value, a parameter in here. So float, and we will do a channel float called break threshold. So if the perimeter is bigger than the break threshold, we'll use carve minus the perimeter, otherwise we set it to 1.0. Let's see how that works. So, and now we start to break with an attribute, and let's do the carving a bit later, and we can animate this breaking threshold. So that's fine. Now we also want to have the initial amount of points if the curve is not being split in half. So for that we can use the same approach in here, or the number of points. So, and PTS, it will be based on the same statement, but we want to output just the same amount of points or the double of it. So MPTS times 2. And now we have the correct amount of points. So let me get rid of this, and now we have a way to break the lines and also the carving, so where we break it. It's fine. Now let's set the carve to 0.72, and we want to animate this break threshold, so let's do just a fit of time between 0 and 1.5, so 1.5 seconds, and we want to animate it from 3 to 0.2. Hopefully that will work. So let's see. And now you can see is breaking, and we are animating that. Let's see how that works. So that's fine. And yeah, guys, that's basically the effect. Now we just need to output some groups and some attributes, which we will do in the next part. So now that we have this, there's still one thing I want to do in here. So before we create two prims, we want to skip the iteration if so we want to create only one prim if it's not splitted. So let's do if carve is equal to 1.0 and the prim split iteration is equal to 1, we just uh, continue, so we don't cook this iteration. So let's see. It's fine. Now, what else do we need to do in here? We need to sample other attributes. So let's take this prim UV and copy this. And after we add the vertex, we will sample the ID. So int underscore ID. We will prim UV the ID lmnum UVW. So let's actually see that if we do set point attribute 0 ID, the point is the point and the value is the ID. Let's see how that works for us. So now we should have the ID working, and that doesn't change if I change this to U, so it's the same, but let's do it with UVW. So there we have our ID. Now we need to sample yet some other attributes. So the next one will be the center ID. So center ID and center ID that we should have in here. So let me check. So I forgot actually to do that. So we need to come back in here where we deform this. And in here, we will just save the center ID, which will be based on the center group. So after we do the lerp, we will do int points, and it will be just an expand point group, and we have that point group called center. And then we just say I at center ID will be a point 0. I want to get the ID, and we can just feed it the first point on that group. So now we should have a center ID, unless I'm doing this wrong. So ID, we have the ID, right? So the ID, and now we get the center ID. So do we have a center group? We do have a center group. So expand point group center, and center ID, it will be the point based on the ID and point 0. Let's check in here. Oh yeah, we do have. For some reason I'm not. Oh, it's just the color. That's fine. We have the center ID, which in this case is 89. So that's fine. Now if we sample it in here, we should have that attribute. So the next one that we will get is the U attribute. So a U map. So let's do, in this case, vector, and let's call it U map, and we want to sample the U, and we want to feed it the U in here. So that's fine. What else do we have? We need to sample also the direction that we have in here. Let's do that. So vector dir, and we want to sample the dir. We can do either U or UVW, doesn't matter. We can fit the same in here. So we have the dir, and then we need yet another one, but this one will be a float, and it will be called sort val. And we should have in here a sort val. We do. So let's do sort val, and it will be the same. And then we just need the rest. So vector rest, and we want the rest. Now we want to set the attribute. So we already have the ID. Set the center ID. It will be center ID. Then we have the U. So let's set U. PT and EU map, and the next one will be the dir and dir. I know this is boring, but we will need these attributes. And then after dir we need sort val and the sort val, and we just need the rest now. So rest and rest. We're just sampling the attributes. Now we are writing the attribute. Now we also want to output one attribute and one group. So if in prim group input 1 and we want to get the boundary and we want to feed it the prim num, in this case not prim num, at I at l num, and if we are in that prim group, we want to save that. So let's do set prim group. This is a way to transfer primitive groups, and we want to set it as boundary, and we want to use the prim and just set it to 1. Now we should have in here a prim group. Let me just get rid of the visualization, and we should have that prim group that goes around, as you can see. Hopefully that's clear. Let me just change the color in here to some orange. Oh, we didn't change the color. Anyways, it's there, as you can see. So now let's check. There's another one I want to set just to end this, which will be set prim attribute. And I'm just gonna set it to prim split, and the primitive is this prim we just created, and the attribute is prim split. Hopefully that's correct. Yeah. Now let's see. We have the ID. So let's see. We do have the ID. We have the center ID. We have the direction, which is just a vector pointing in. That's fine. We have the rest. We have the U, which is the value that we previously had, as you can see. It's just mapped in another way. Oh, because this one is 3 float. So in this case, we want this as float. Yeah, that's correct now. Then we have center ID, we have the sort val, which will be a value around the deforming geometry, which seems to be correct. Let me see. Yeah, it's correct. So that's fine. We have also the group, and we have this prim split, which is just a value 0 and 1 between the two geometries. So yeah, guys, I think that we have accomplished it. The task of creating this was quite a bit of work, but again, the result is quite cool, in my opinion. So we can try to mesh this, but let's do that in the next part. So now we have this effect, but I want to deform these tips to be more pleasing, more pointy, so we get a better result at the end. So for that we will need to carve we will need to extract the center ID and carve from there. So in here let's do a blast, and we do it based on points and delete non-selected, and we say at underscore ID is equal oh not 3 equal to a point expression, so point 1, and we want the point number can be 0, doesn't matter, and we want center ID and just the first element, so we get the center curve. Is this correct? So let me check in here. Yeah, this should be correct, but let me see. Oh, this is not correct. So, oh, not 1, sorry, 0. And now we have the correct value. So we have the center ID. All right, now we need to carve this. So carve. And we will carve on both ends by about 0.598, something like this. And that's fine. Now let's do another angle, and we will connect this in here and connect this one in here, and let's name it deform tips. And now let's see, we will basically create a mask for this inner portion. So for that we will need an intersect function. So let's create the variables that we need: hypos, an IUVW, just the way I like to name them. Then we need a vector origin, which will be just v at p. Oh, what have I done in here? Which will just be the current position. Then we need direction, and it will be just the direction attribute that we have times some big number, so we always intersect. Then we do the intersect, which will output the prim. So we do intersect on the first input, and we will do origin, direction, yeah, can be there, and IPOS and IUVW. These are the values that I'm going to write. Then we just do float at imask, it will be I prim not equal to -1. And let's see that. So I mask, and we get this mask in here. But as you can see, it's also happening at the beginning, so we need to constrain this somehow. And I also want to save vector at IPOS will be equal to IPOS, because we will need that to deform these tips. So now let's do the following. Let's create in here another angle, and we will just say f at imask is equal to 0, 0.0. And now we can switch between, so we don't deform at the beginning. This was the way I found it worked well for me. So we will just do $f is bigger or equal to 32. So let's actually see. So we have not, maybe we can do it. So maybe we can do it at a later stage. Let's see how that works. I will have to adapt in here. So let's see. Frame 37. Let's try 37. So that's fine. It's a bit different from my file, but if I will try it this way. Now we have that IPOS that we saved, and we can attribute blur that position. Before we attribute blur, let's actually deform this. So let's do a wrangle, and we will deform. We need to rename that one, but let's keep it for now. And we will do in here. So we might not have that IPOS attribute at some, so we need to ask if as point attribute 0 and IPOS, and if it has, we will deform it. Oops. So we will just say v at p. It will be a lerp between v at p equals to lerp between the current position and the IPOS. And as a bias, we will use a channel, a parameter. And now we can just say, and as you can see, it's doing something like this, but we need to work on this effect. So before we deform, we need to blur quite a bit the IPOS. So let's do, we have the attribute blur in here, and we will do, we want pin, and we will do proximity and IPOS, and already is working a bit better, and we will do 100. But as you can see, it's blurring everything, so we need to place in here a weight attribute. And that weight attribute, we will just use the U component. So we should have a U in here, this one, but we need actually, let's actually try that. So weight U, and we get this result, which is not bad, but I think I wanna remap it. And let's remap the U. Let's computer range, let's set this to 1, and we will increase this one to 0.47, let's say, and decrease this one, oops, 2.76. And we also need to blur this U, of course. So attribute blur, and we want to blur the U, and we don't want to pin border points, and let's just do 6. And now we get this effect. Fine, but I also want to animate it getting pointy. Sorry if I don't have a better description. But basically here in the bias we can do a fit of the frame, and between frame 36 and 40 from 0 and let's say 0.4. We don't want that as much, so let's see how that looks. And with after the remeshing, this won't look as choppy as it looks right now, but we can always go back and change this, so don't worry too much about it. So yeah, guys, we already done plenty of stuff in this lesson. Let's see in here, and let's look at that, our results so far. And hopefully you found this useful. Again, I'm gonna come back to this a bit later, and please let me know your interest in the comments if you like me to do this a bit sooner than the time that took me to do this lesson. As always, thank you for watching. You can grab all the files on my Patreon alongside with exclusive courses and videos and all the project files from my channel. So again, thank you for staying with me, and if you made it to the end, please leave a comment and tell me what you think. Thank you for watching, and I guess I'll see you next time.